Yeah, thank you. So we will be talking about Radare and Frida in the OWASP Mobile Security Testing Guide. First, I would like to ask you who's working on mobile security or is interested in mobile security and do know the mobile security testing guide already? Okay, quite a few, that's good. So I hope this talk is still for you, so you find something new, and for the rest, so that you can get to know it. My name is Carlos Holguera. I'm not Mark, as in the other picture with a mobile security engineer at Script since 2012. And my areas are mobile security testing and automotive security testing. Sometimes also together, like apps talk into cars, and security testing automation. And recently I've become project lead of the mobile security testing project together with Sven and Jeroen. So yeah, that's why I'm here, and I would like to present you this good stuff. So let's go from the standard to the guide. And so first, when you start on mobile security, or you just want to test apps, or it's your job to test apps, you will be looking for good sources, what is the right methodology, what you should exactly do, which techniques to use. So you would search on the internet for videos, for trainings, etc. And I wouldn't say that's bad, that's okay, but you would probably rather have a place where you can always refer and take this information. And I mean, trainings in general, unless you go to these trainings and the r2con, they are normally not so good or advanced or specific at some points, are rather general stuff that actually I can tell you already you can find here for free. So, and sadly the r2con it's just once a year, so unfortunately. So the place to go, it's here, and we will be taking a look at the three main deliverables that we have, and we will start with the standard. So this is the MASVS, Mobile Application Security Verification Standard, and try to picture it like that. So you see some requirements, or should see some requirements. There are security requirements that you can apply to mobile apps. So this is intended for you to have a reference where you can always take a look. What do you have to test? You have an app, so you would classify it and see what exactly you have to test for that app. And we will see that it has several categories. So this is in GitHub. I put some links there that you can just click over here. Actually, the whole presentation, when you get it as PDF or something, is full of links, so please click all over. You can also download it as a PDF, for some reason as doc, Windows, Word, I don't know. Yeah. The point is the security requirements, they are agnostic from the operating system. So they are not talking about Android or iOS, but rather in general. And then you have to apply them to those. And we will see how this is done. So this is how the requirements look like. In this case, well, on the left side, you can see the categories. I don't see if you can see my pointer here or not, but well, you can see the categories, V1, V2. So we will be talking about data storage, networking, protecting the app, so resiliency, etc. So in this example, we have some of the network requirements. And for all the requirements, they will be categorized by some levels that you see on the right side. So yeah, for about these levels is like the level 1 is for almost every app. Still, you will have to look if they apply to your app. If you just have a flashlight app, probably you won't need much security requirements. Still, you will have to prove, for example, that is not accessing the internet or something, and that's a security requirement. So then we have level 2, and this is for apps handling sensitive data or some sensitive functionality. And then we have the R level. So this is when this data is highly sensitive, and then you have to protect. Also, maybe you have to protect intellectual property or make it tamper-proof. So some examples of this, because you will be still wondering, okay, have a flashlight alarm app, for example, that would be also level 1 probably, and level 2 could be a health app. So you are maybe or maybe not protecting some intellectual property, but you are handling sensitive data, that's your health data. And then you can also mix them depending on what you need. So if you have a game app, you would also need to protect the intellectual property of your game. So then you would apply level 1 and R, and then you have to consider if it's a banking app, you will apply level 2 instead of level 1 plus the resiliency also, because you are having both handling highly sensitive data and also protecting intellectual property and making tamper-proof, so you cannot just pass money to other accounts. So yeah, these are the verification levels, and yeah. So we saw the security requirements, so we can have this nice list of security requirements. So here we come to how do we test them. So they were all operating system agnostic, so we will come here to specific stuff. So the testing guide, it's actually like a book. Actually, you can also have it as a physical book or a PDF, or again, for some reason, as Word document. Some people love that. Well, yeah, it's a manual for testing. So you come here if you want to know, for example, we saw in the other talk today that you have to decompile the app, that you can extract the assets, that you can do a lot of things about this Mali, all these things. So this is what you will learn here. For example, you can go, we will see the chapters in a bit, but there's one basic security testing, and it's the same on Android and on iOS. So the structure is the same, so you can follow it and see how can you get a package of an app and what you do. So it will explain, okay, it's a zip, you can unzip it, and you can follow these steps on Android, this on iOS, so you can just follow them. There are examples, and you can also reproduce them with the apps that we also mentioned in the guide, or just any other app. So yeah, for each of the the security requirements, you will find the descriptions here. We will see also how. So this is an example. We have the general testing guide that covers things that are common for Android and iOS. And this is the example of the structure of the chapters for the iOS testing guide. You will learn first, for example, in the platform overview, what is iOS, what it is about, what is the security that is included, etc., some APIs. Then basic security testing out these things. Okay, you can unpack an EPA file, that's the file format for iOS apps. And then you will learn about security regarding data storage, network, cryptography, etc. And of course, tampering, reverse engineering. So about how we are mapping this from the security requirements to the testing guide. This is pretty new now. You have this MSTG IDs, and you can just follow them and search for them in the guide and the other way around. So on one side you have the the verification standard. So you will see, okay, MSTG platform 3. I will search for that. Actually, if you click on this like a button, it will do this search for you. So you can just search the same way, and it will address you to both on Android and iOS the sections relevant to this. So if you see in the title of the section is also the ID there, so you can follow. So then we come to the third part. So who doesn't love Excel files? So we also have an Excel file that you can use as a checklist, and also to give us with your results of the testing. And it also includes like whenever you put what you tested and not, and you will see some statistics also calculated, but mostly is also intended for you to have a checklist, because I don't know I forget things all the time, so you really don't want to forget anything, so you just take the checklist and make sure that at least you tested all that is in the MASBS. And of course, again, regarding the requirements, you will have to see if they are applicable to your app or not. You will also mark it here, and if they are not applicable, so you would just give a reason for that. The good thing also in this file is that you can also click on the links, and it will do also like this search. So we will address you in the testing guide how can you test that. So you can just go through the list, do the checks, go to the guide, test, go back, etc., and then deliver this file also if you want, or use it for other purposes. So about I told it before, we have it also in different languages. If you see a language that is not yours, please PR, pull request. We will be happy to have this, both from the checklist, the verification standard, and the mobile testing guide. That's a bit more complicated, as you can imagine. It's very big, so the translations are more complicated, but at least verification standard, we have already a lot of languages. We will be happy to have more. So contributing, this is a very important part. If you just go to GitHub, you can see our projects, you can see our issues. So we invite you to just take one and contact us. So very easy process. We will assign it to you. You can work on that issue. When you're ready, you will get you will not notice that, and you will get feedback from us. It is actually very nice, because also if you are starting, you can learn a lot, and you can have discussions with us regarding the topic at hand, and this is very good for learning also. So don't be afraid if you are starting. It's a good place also to start learning. And of course, if you are more advanced, we are also happy to have your expertise here, and also happy to have discussions. Then, of course, if then will be approved, then we will merge that and will be in the guide. So please contact us anywhere on GitHub or on Slack there. And yeah, something more to say about contributing also is we have a style guide, so you can take a look how to write things, and also important the code of conduct, that there's nothing commercial or this stuff. So yeah, so the idea here is we will go from the standard to the guide, so from the security requirements to the actual test cases, to the actual task or steps that we will be doing, and link all of this to the tools. So the idea of this talk is to show you the places in the guide, or well, some of the places. I can show you all of them, but you can take a look afterwards. And that at the end you see where is Frida being used, Radare, etc. So for this, I've picked up three of the security requirements. So we will call them here A, B, C, but actually you will see that they are, for example, platform 3 in this case. So here it says the app does not export sensitive functionality via custom URL schemes unless these mechanisms are properly protected. And this is level 1 and level 2. So then you would wonder, okay, I want to test this. How can I test this? So you will search. You can click there or just do the search yourself on GitHub or something. And one of the steps you will need is to perform yourself some URL requests. So you can do that with the Frida CLI, and it's very easy. It's there documented in the guide, so you can actually just copy this piece of code, put it in the CLI, and use it. So for this we have a little demo. Oops. So as I said, here we spawn the app, this iGoat Swift app, and we just copy this and we can directly use this function. And in this case, we will just call the telephone URL scheme, and it will just pop up. Very, very simple case. So one of the other steps you will have to, this is only a technique or one step you can take for this. So when you are testing custom URL schemes, you want to identify what is the handler method. So when an app is receiving an URL scheme request, so what is the method that is handling this request? Because if you don't have access to the original source code, this would be a rather difficult task to identify. So you of course can try statically and reverse it, etc. But I'd rather make it easy and just use Frida and just get this information. So for this example, we will be using Mr. Marchette's script here from Frida CodeShare. And it's very cool. You can just observe something, and we will observe the OpenURL method. That's the method, or something that looks like OpenURL method. That's why we have like the asterisks there that will match anything that looks like that. And that's the idea, because we don't know exactly which class will be, so that's what we want to find out. And that's what we are doing here. We continue, and now in the other console, we will run this, and in the console app on the top, we will execute again the OpenURL. So as you can see here, you cannot see it, but we already loaded the script, and now we are using the observe something function. And we will trace all calls to this OpenURL method, so you can then identify which one it is. So this is just meaning, okay, we are observing this, but nothing's happening, so we switch and we will call this. In this case, the iGoat has an own custom URL scheme. We will call it just empty, and we will see, okay, it's asking if we want to open it. So something happened, as you can see, but still it's not complete. So now we open it and it's complete. So now we can take a look, and you can see that we can also not only identify the method, but we can, I will go again there, sorry. we can see exactly what has been called. So it was the iGot URL handler. That's what it's highlighted right now, and it's empty. It could have more data afterwards. And we can see, if you look at the first line, we know now that this method is in the app delegate of the app, and the method is application open URL options. So, and you can also see that who's the calling app, the source application as it's called here. And it was the OWASP iGot Swift, because this is the ID of the app. And why? Because we attach, on the top, we attach to the app and we call this handler from the same app. So we are the same app. So so for the same, but another example is that we do the same but from Safari. So we will just call this from Safari and let iGot open it and verify that Safari was the one calling this. So, and that's what you can see there. Com Apple Mobile Safari is the one that called this URL scheme. So now maybe you would like to use this for further reverse engineering. It's a good technique to identify this kind of methods. And here is for the open URL, but you can use it for whatever you want. So this is the second example, and it's the platform 5. JavaScript is disabled in web views unless it's explicitly required. So one step we can take here, or we would do at first, is to identify is the app using web views at all. So we don't have a demo for that because you can see it here, hopefully. We can just use Rubbing or actually Radare, it doesn't matter, to search for the classes. So the classes, if you take a look, the lines containing the classes will end with UI WebView or the WK WebView. So we just extract the strings with Rubbing and then grab them with this regular expression. Very easy. So now we know, okay, there are some web views there, good. And then we would like to enumerate the instances. So whenever we will open a web view on the app, you cannot know just by looking at it if it's a UI web view or a WK web view. And as we explained in the guide, you should use one and not the other for some reasons. So if we run the app, we would like to go, know exactly which web view is using. So for this, we can just actually, again, take this code and it will just go through the through the memory of the app and take all the instances it will find of this. So on the first one, we will see that we spawn the app. And in this case, is this Where's My Browser app that is including some vulnerabilities in purpose. So here we will demonstrate that we have a UI web view. So we have opened one, and now we have copied just the code and executed. So now we are waiting for Frida to find these instances of these objects, and it will say in some seconds that found something for UI web view, and now actually is still searching for the WK. So, and here you can also see what is actually the URL that is loaded within this web view, and that it's done with both searches. So what we do now is we load the other web view and see if it's also finding this web view, and again taking a look at the URL. So take some time, but we found again the UI web view because we didn't close the app or anything. It's probably still there. And yeah, it's done. So we also found the other web view, and we can also take a look at the URL. So This might be also useful if you are testing some web views, and in the web views normally you don't see the URLs and you are interested in seeing how the URL looks like or other parameters that were used when creating this web view. Because maybe as this is the case here, we are testing actually for JavaScript that is disabled on the web view. So we would like to know if this web view has JavaScript enabled. Again, we could try to reverse this, but why not do it this way, because it's much easier and quicker. So actually, to test this, we would finally do the same. So we can use the same code, but we have added here one line more that will tell us if the JavaScript is enabled. And this is just a property in the configuration, preferences, JavaScript enabled. So we just call it whenever we have hooked this. And so whenever we have one of these instances, we just get this parameter and then we know that it was activated or not. So again, with the Frida CLI. And now the third example. So this is for storage. The app does not hold sensitive data in memory longer than necessary, and memory is cleared explicitly after use. And this is a level 2, as you can imagine. Not any app just needs these protections on memory level. So for this, one thing we can do is to take a memory dump and take a look in it. I think for this I just zoomed a little bit so you can see it also here. And for the next one, I think I have a demo also. So here in this example, we're using freedom. You can use freedom or objection, for example, or just do it yourself with Frida. So you would take this dump. You see there, it will take some time. Once it's complete, you will have several files. And if you also specify this S flag, you will have a file containing only the strings, etc. So then you just can take this dump and use, for example, Radare with the search functionality. So in this example, what I did is I opened an app and had like a user and password, and in the password I gave OWASP MSDG. And that's why I'm looking here in the memory dump for OWASP MSDG, and I'm finding it first. So no, first I'm not finding it, so you can see that our hits are 0. But then I do a search for white string, that's with the W after the slash, and then we find the string. So this is this kind of things that may also, maybe if you don't know, at first you know you can search but you won't find it, but maybe you will learn in the guide that you can do these kind of things and will be helpful to you. So yeah, and then we have runtime memory analysis that we can also, a technique we can also apply for this security requirement to test it. And for this, what we do is, okay, we don't take a dump, we just search in the memory. So we have seen this in the training, the ones you were also there. So we also have this explained a little bit in the guide. So in this case, we will do the same, that we put this string and we will search it in the memory instead of in the memory dump. So let's take a look. We go back to the iGoat app, and we just, this is just random. I just selected one of the screens. It doesn't matter. It's just to demo this, that we enter some string, should be a password in this case. And we could do a login, but we are not doing it now. We just want to know if the string is in memory or not. Well, it should be, but to see if we can find it. So we entered the string, and now on the other side we are waiting, but now we attach with to Frida, and we will just search for this string. It will take some time. and still searching. I think it's almost ready, or not. So one hit. I don't know if you can, now you can see it, but I went to the other place. So anyway, we have found it. Maybe I have to just go here. Yeah. So there it is, one hit. We could then, I don't know, if you want to print it or something, or do something with it, or maybe you would like to know exactly what it is in memory. We will see about that. But the next thing we will do is, imagine you actually want to do this logging, and then you want to see also how it is possibly. So there you saw what it was in memory. Now what you want to see is if it's still there after the login directly or not, and where, and if there are more than one or whatever. So you want to learn what happens to this. So we clicked on logging, didn't work because we didn't have connection, but doesn't matter. It's just for showing this use case. So we search again, and now we will see another thing. Maybe we'll also do like this. And yeah, so now we have 3 hits. So this can be found 3 times in memory. And as I said, maybe you would like to know exactly where it is located for some reason. So you can also do that. Just do some Radare magic and take those hits, and we will just loop over them and look inside the memory maps to see in which sections they are located. And that's it. I will pause it. So that's with a DM comment and with a dot. It will tell us where we are in each moment. So where is our offset? And with this other add hit. And the glob, we will iterate all over this. So we can see that they are in some read-write sections of the memory. In this case, it doesn't matter because it's just a dumb example, but in other cases you will want to know for other strings, maybe if they are located inside a library, if they are not runtime variables, but some strings or some crypto stuff you are searching for. I'm just talking in general now. So you want to test where they are. You will find it in a library, in the main binary, or you see they are only in variables. And then what you can do is, if you're really doing a login like here, you would test afterwards if the variables are still there. So you will search again in the memory once the login is finished, and to know if your password is still in memory or not. And if it's a level 2 app, it shouldn't be there. So that's the way you can test it. And what else? Of course, there is a lot more. We have, of course, Cutter also. If you click there, you will go straight to the sections where we are using this. So how to reverse engineer with Cutter. Swift demangling with Radare. I've also seen there is a new command. I didn't test it yet, but this command would be also cool to have. Yeah, in Passion Fruit, in case you don't know, it is quite cool for testing iOS apps. Just connect it, see all the apps attached to the app, and get a lot of information. You can take a quick look in the guide also to learn what exactly you can do with that, and it's also applied to several test cases. And yeah, the next features or next things that we are using are your next contributions, hopefully. And yeah, this is to honor my nickname of Grab Harder. Just put some random Grab tips there. just use them and see what happens. They are cool. And yeah, so some takeaways. Use the guide, the standard, read the guide, Grab Harder, learn Frida and Radare, and contribute to all of them, and also to the guide, please, and have fun. Thank you very much.
Thank you.